Welcome back to 3.6 Divisors. So we talked about multiples earlier on in the chapter. A divisor is kind of the opposite of a multiple. So we know that 12 is a multiple of 4. Talk about that because 4 times 3 is going to be 12. So you can get to 12 from 4. So 12 is a multiple of 4. But that also means that 4 is a divisor of 12. So basically we can divide something from 12 to get to 4. Because 12 divided by 3 would be 4. We also say sometimes that 4 is a factor of 12 because 4 times 3 is 12. Divisor and factor mean pretty much the same thing, so you can kind of just use those interchangeably. If I ever say factor or divisor, I'm talking about the same thing. You can also have negative divisors or factors because you can say -1 times -12 is positive 12 and so on. -2 times -6 would be positive 12. And here's all of the negative factors of 6. So if we jump into the first problem, let's go ahead and find all of the positive divisors of 84. So let's see how we can do that. So we can just start from 1. We know we have 1 times 84. We're going to have 2 times something. It's an even number. We know it's divisible by 2. And that's going to be 42. All right, 3 is divisible by 3. Let's see, 8 plus 4 is 12, and 12 is a multiple of 3, so should be divisible by 3. So what would 84 divided by 3 be? That would be 28, if we divided that. And 4. We know that half of 84 is 42, so that's still even. So we know we can cut that in half again, so that would be 21. Which if you did 84 divided by 4, you would get 21 also. How about 5? It's not divisible by 5, doesn't pass that rule. How about 6? Well, yeah, how do we know if it's divisible by 6? Well, it's divisible by 2 and 3, so maybe it's divisible by 6. And indeed it is. It would be 6 times 14. And 7. So we don't really have a divisibility rule for 7, but if we did 84 divided by 7, we'd go in 10 times to be 70, and then 14. So we'd add another 2, so that would be 7 times 12. How about 8? 8 times 8 would be 64. Let's see, 84 divided by 8, we know that it's going to go in 10 times to be 80, but then we're going to be left with 4, and so 8's not going to work. How about 9? Remember the divisibility test for 9? 8 plus 4 would be 12. That's not a multiple of 9, so 9 doesn't work. And how much farther do we need to go? So 10 squared would be 100. That would be bigger than 84. But what about 10 times anything less than 10? Because we know 10 times 10, 10 times 10 is going to equal 100. So that's bigger than our 84. But do we need to test? And we know for 10, and this is kind of a silly question because we know this is not divisible by 10 because it doesn't end in a 0. But let's just say it wasn't the number 10, it was something else. How would we know when we're done? Well, 10 times 10 is 100. And you could say, well, what about 10 times 9 or 10 times 8? 10 times 8 is not bigger than 100. But we don't need to check 10 times 9 or 10 times 8 because we already checked the multiples below this. We've already checked 1, 2, 3, 4, 5, 6, 7, 8, and 9. So if it was going to be 10 times 8, we would have already found it because we would have found that when we checked 8s. It would have been 8 times 10 or whatever number we're checking. We would have already found it. So all we need to do is check the square of the number that we're checking and beyond. So either 10 times 10 or 10 times 11, 10 times 12, or so on. But if we already know that 10 squared is bigger than our number, then we're done. We don't have to do any more. Hopefully that makes sense. We talked about this. There's something similar, I think last chapter, that indicates when we're done by doing the square of the number and knowing that we don't need to check 10 times anything lower than 10 because we already checked all of the multiples below 10 already. So anyways, so these are all of the divisors of 84. So if we list them out, it would be 1, 2, 3, 4, 6, 7, 12, 14, 21, 28, 42, and 84. Those were all of the factors or divisors of 84. Okay, so count the divisors of each integer from 8 to 18. Which of these integers have an odd number of positive divisors? Okay, this might be a lot of work here because now we need to find the divisors for all of these numbers from 8 to 18. Let's see if we can go through it quickly. So for 8, the divisors would be 1 and 8, 2 and 4, and anything else? I think that's all of them. 1, 2, 4, and 8. For 9, we're gonna have 1 and 9, and we're gonna have 3 times 3, so 1, 3, and 9. For 10, I'll go ahead and write these out. I'm sure you could probably figure these out on your own, but I'll just do these quickly. So it's gonna be 1, 2, 5, and 10. For 11, it's going to be 1 and 11. It's a prime number. For 12, we've got quite a few of them. We have 1, 2, 3, 4, 6, and 12. For 14, let's see, we've got 1, 2, 7, and 14. 15 is 1, 3, 5, 15. 16, we have 1, 2, 4, 8, and 16. 17, we have 1 and 17. And lastly, 18 is 1, 2, 3, 6, 9, and 18. Okay, so with all those written out, which of these integers have an odd number of positive integers? Okay, so this is even number. Here, this one's odd. I'll circle it. That's even, 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 even. Odd here, that's 5. And even and even. Okay, so only 2 of these have an odd number of divisors. For B, there's one integer between 20 and 30 that has an odd number of positive divisors. Which one do you think that is? What do you think is similar between these two that only have an odd number of divisors? And why do they have an odd number of divisors? So let's think about that. So the divisors for 9, we know 1 times 9. It's not divisible by 2. It is divisible by 3. Be 3 times 3. So that's interesting. So it is multiplying the same number. It's a square, right? Because 3 squared would be 9. It's using the same number twice. That's why it ends up being an odd number, is because we use the same number twice. And how about 16? That's also a perfect square. And we use 4 twice. We do 1 times 16, 2 times 8, 4 times 4. So we use this number twice, and it's only listed once. That's how we get an odd number. So if there's one integer between 20 and 30 that has an odd number of positive divisors, which one do you think it is? It's going to be 25. So for C, which positive integers have an odd number of positive divisors? We kind of already discussed that. That's going to be perfect squares are going to have an odd number of divisors. So it's going to be 4 and 9 and 16, 25, 36, and so on. Okay, note that 20 is a divisor of 60. Must every divisor of 20 also be a divisor of 60? Okay, well, let's find the divisors of 20 and see if that seems to hold true. So for 20, we have 1 times 20. We have 2 times 10. We have 3 times 20. Right? No, divisors of 20. That would be a divisor of 60. So 3, okay, 20 is not divisible by 3. How about 4? 4 times 5. It looks like that's going to be it, because 5 squared would be 25, so I think we're done there. All right, so we have these 6 divisors, 1, 5, 1, 4, 1, 2, 4, 5, 10, 20. Are those all divisors of 60? Well, 1 is 1 times 60. 2 is 2 times 30. 4 is be 4 times 15. 5 is because it ends in a 0. 10 is it ends in a 0. 20 is because it'd be 20 times 3. So yeah, looks like that is true. All the divisors of 20 are also divisors of 60. But must every divisor of 60 also be a divisor of 20? Well, let's start with divisors of 60. We have 1 times 60. Well, already got one that's not. 60 is not a divisor of 20 because here's all the divisors of 20 and 60 is not in there. So no. All right, suppose 3 is a divisor of k and 3 is a divisor of k plus 3. Is 3 a divisor of k plus 3? Okay, so if k is a divisor of 3, so if k is a divisor of 3, then 3 is a, or then k would be a multiple of 3, right? So let's say k is 9. 3 would be a divisor of k, right? So then what if we do k plus 3? We would get 12. And that's still a divisor of, 3 is still a divisor of 12. So that seems to check out. Let's try a couple other examples. Let's start at 15, right? 3 is a divisor of 15. We add 3 to it. We get 18. And we can also tell, like, if we are at a multiple of 3 and we add 3 to it, of course, it's still going to be a multiple of 3 because we added 3 to a multiple of 3. And so it will always remain a multiple of 3. So yes. Suppose 3 is a divisor of both b and c. Must 3 be a divisor of both b and c? Okay, so if b is a multiple of 3, let's just say 3. 3 is a divisor of 3. And c, let's say, is 9. Okay, 3 is the divisor of both of these numbers. So what if we added those together? We get 12, which is another multiple of 3. So that seems to check out. Let's do another example. Let's say 15 plus 12, let's say. That's 2 multiples of 3. And we would get 27, which is another multiple of 3. And we also talked about this in multiples. If we add 2 multiples together, then it's still going to be a multiple of whatever number we're talking about. So the same thing holds for this. It's the same rule, but we're talking about divisors instead of multiples, but it still holds true for divisors. Now, suppose that 3 is a divisor of b plus c. Must 3 be a divisor of both b and c? Well, let's say b plus c is 15. That's a divisor of 3, right? So let's say 15 is equal to 1 plus 14. Well, 1 and 14, those are not divisors, 3 are not divisors of either of these numbers. Or these are not multiples of 3. So no, not necessarily true. All right, and I think that is it. Very short lesson today. Hopefully you like that. That's a pretty short one. And hopefully not too hard. This is very similar to multiples. So if you understand multiples really well and you did the practice problems for 3.1, then this lesson hopefully was no problem. But go ahead and try these exercises and make sure that you got a good handle on this before jumping into the next section, which will be the last section for chapter 3. So I'll see you next time.